There are many different types of locomotion in VR projects. These determine how users move about in the world, which can be quite different than common techniques in traditional video games. In this module, let's discuss a couple of the most common ones, as well as go over how a player moves around the scene in Unreal Engine's virtual reality template. Starting with the simplest form of locomotion, keeping the user stationary. This means that we have no movement other than what is possible with the user's body in their own space. The only motion in these cases is one-to-one, directly driven by the world space location of a user. An example of this would be Oculus First Steps, where the experience is designed to be within our Oculus Guardian. Rail locomotion puts users on rails, moving them through the environment automatically. As they move, the user can interact with objects in the world. It's important to consider the degree of rotation influence and speed change you use with rail locomotion, because it can quickly create motion sickness. Standard rail locomotion examples are VR roller coasters, and because there is a differential in the movement of the virtual world compared to the real world, they have been known to induce motion sickness. VR rides with motion platforms which physically roll and pitch the user in sync with the VR experience help to create a consistent sensory experience. A simple but limited method is gaze teleportation. It functions similarly to general teleportation, but the point that users will teleport to is determined by their gaze. Whatever area they are looking at is where they will warp to. The selection is done by holding down a trigger or other button on the controller and then looking at the desired location in the world. This technique was more popular before more advanced input devices were introduced. Precise movement using your head can be challenging and even uncomfortable at times, so it has become less common as a mechanic unless intentionally motivated by the experience. Unreal Engine's virtual reality template uses teleportation locomotion, which is generally performed by the user pointing their controller at a spot in the world they'd like to go while holding down a button, which will allow them to select a specific teleportation point. Upon release of that button, they will be warped to the selected location. Often it is beneficial to enable users to change their orientation while teleporting. This allows users to not only change the location, but what direction they are facing when they reach the new location. Last on our list is what we will create in the next module. Standard controller movement is familiar for anyone who has experience with traditional video games. The user moves around by using the analog sticks on the controllers in their hands. Because it's been refined over decades in video games, this approach may appear simple at first glance, but there are several techniques that developers can use to increase comfort for VR users. For example, in VR, it's generally best to map the movement speed directly to the joystick. Some traditional games include techniques for adding weight to controls by slowly ramping up or down the user's speed. In VR, this will feel unexpected and unnatural, which can quickly translate to motion sickness. Another method for reducing motion sickness is to use a render effect called vignette, which creates a tunnel vision effect in the user's eyes. By removing a large amount of the user's peripheral vision, we can help diminish motion sickness. We'll build that together in the next module, but for now, let's dive into the VR template's motion controller pawn and BP motion controller to learn how its teleportation locomotion has been set up. Let's start at the top of the pawn itself. The first thing it does is set up the pawn to accommodate whichever head-mounted display the player is using. So we're going to be using Oculus HMD, which is going to set the tracking origin to floor level. Immediately after, it will spawn two instances of BP motion controller, which is what we are using to represent our hands in physical space inside of the virtual world. It then caches them both respectively as a variable and attaches them to the VR origin scene component. Attaching them to the VR origin component will make sure they come with us wherever we go. Pan down to the input action teleport left and right function. These events are called when we press the correct key on our motion controllers. Because this is an action event, it will call once when it's pressed and once more when released. So for our teleportation purpose, when we press and hold the left trigger, we are telling the left BP motion controller to run the function activate teleporter. and then the right controller to run the function disable teleporter. When we release the left trigger, motion controller pawn will check the value of is teleporter active, and if so, it must have been actively searching, so it will run an event named execute teleportation and provide itself as the input for later use. Pan up a bit to the execute teleportation event. When this is called, motion controller pawn will retrieve all data gathered from the controller, and if it contains a valid teleportation destination, initiate the process of teleporting. The first thing that happens during teleportation is to set is teleporting to true, so we can't call this again while it's in progress. Fade the screen to black, wait until it's fully faded, disable the teleporter on the controller, move and rotate the pawn to the new destination, fade the camera back in, and finally set is teleporting to false, allowing us to teleport again if needed. Notice with the opposite hand that the same sequence of events will happen using the same input for that hand. This is a very efficient way of creating an asset once and using it for multiple purposes. In this case, once for the left hand and once for the right hand. Now we know how the motion controller pawn tells BP motion controller to collect data and then use this data to move our pawn around. Let's quickly see how BP motion controller collects the data it provides. Starting with the function activate teleporter. Double-click to be sent directly to it inside of BP motion controller. Immediately, is teleporter active is set to true. The visibility of the teleport cylinder and its child's components are set to on. If room scale is being used, the room scale mesh is turned on, and the initial controller rotation at the time of trigger press is cached for later use. The teleporter is ready, and we now know that these assets, if they were on, are now off on the other hand. We're going to be breaking down what the functions do in detail in a later module, but for now we have an overview of what all occurs when we press and release the trigger on either hand. So I'm going to navigate to Virtual Reality BP Maps Motion Controller Map. And it's still modified from our previous module. So I'm going to press VR Preview. So when I teleport in VR holding my right hand, you can see that the arc is now coming from my right hand. If I use my left hand, we now know that the right hand will be disabled, and if I press my right hand again, the left hand was now disabled. Notice that the point of the teleportation will change the rotation based off of the direction I'm looking. So if I wanted to change the orientation that I'm actually facing, so right now I'm facing in this direction, in physical space. But I want this direction to be actually facing the direction towards the main table over there. So I could do that by clicking the thumbstick and then rotating with the thumbstick to change the orientation of my teleportation. Next, we'll set up our own way of exploring the scene using standard controller movement.